So in the last class we talked about what? The conditions for minima, right? Condition to form minima over here. Now in today's class we'll be talking about the difference between interference and this thing, uh, diffraction, and then we'll talk about you know the resolution part. Chill. And then I will do some questions as well, na? I think questions are here. Let me check where. Questions will be basically directly based on this thing, na? The formula which will give you what is the position of this minima, that minima. It generally comes like that. So, anyways, please write down heading. Difference between interference and diffraction. Okay. So, uh, basically, what is the difference between interference and diffraction? First difference is it happens due to superposition of waves from two coherent sources, whereas diffraction happens due to superposition of waves from multiple sources. Is it clear? पहला difference clear है guys? Guys, is the first difference clear?
Yes, sir.
Yes, sir.
In the second case, uh, all fringes are of different width, oh sorry, or of same width in interference. The fringe width is constant in the case of interference, right? Yes or no? But here the fringe width is the fringe width is not the same. We'll draw the diagram and we'll see how exactly is the diagram for this. For is not the same for all fringes. Third is all bright fringes have same or similar illumination, basically similar intensities, है ना? So intensity is basically constant, right? Intensity of all bright fringes is constant. And what is that equals to? 4 times of I naught, if you remember. Whereas here the intensity decreases as we increase theta. Do you remember? Intensity was given as a function of theta, and I already talked about when theta is increased, intensity decreases. In the last class, I think we have already talked about this, right? उसके बाद में why so many people are absent, guys?
So I think exams are going on.
फिर भी इतने सारे. I just received message of only there and Navina, I guess. They said कि they will be not joining classes. Guru also said, Vaishnavi also said, okay. ठीक है. Is this clear, guys? Intensity is the function of theta. Next, after this, what about all dark fringes? So can you see here all dark fringes in the case of interference are completely dark, provided the intensity from the two sources is equal, right? So here intensity of dark fringe is basically zero. Again, this is a constant. Here, what will happen? Here, all dark fringes are not completely dark. Here you have good contrast between dark and bright fringes. Here you have, guys, is this clear? Here you
Yes.
have poor contrast between dark and bright. Sorry. Hmm. Dark and bright fringes, whereas in diffraction we have poor contrast. So ये सब I think it's pretty much clear the differences, right? Clear है क्या? अच्छा हाँ, एक बहुत ही important point है. Do you remember when we talked about diffraction? Oh, sorry. When we talked about interference, this was basically the slit separation denoted by d, small d, right? Yes or no?
Yes, sir.
Yes,
है
sir.
ना? And the waves from here and here, they were making something on the screen, right? So let's say this point is A and let's say this point is B. This is S1, S2, and will this be the path difference? So here the
Yes.
path difference is basically equals to d sine theta. And what happened in this case? When delta x was equals to n lambda, okay, when it was equals to n lambda, then you got a bright fringe. And when delta x is equals to n 2 n minus 1 lambda by 2, then you got a dark fringe, right? Similarly, in the case of diffraction, it's different. If suppose this is the a single slit, this is a single slit and it has a width a. So if I talk about this point a and this point b, so do you remember if these 2 points they make certain superposition? So here delta x between a b is which is equals to a sine theta. Please remember what is theta, guys. What is theta? This angle is theta. याद है सबको? So this angle is also theta. This angle is also theta. So here it is a sine theta, right? When this a sine theta, which is basically equal to m lambda, then you got a dark fringe. उल्टा हो जाता है, ठीक है, ध्यान रखना है जी. And similarly, When this a sin theta is equals to 2n plus 1 lambda by 2, then you get a bright fringe. Although ये कंडीशन इतनी सिंपल नहीं है जितना दिख रहा है, it's more to this condition, है ना? Not simple as directly simple like this. Is it clear, guys? ये समझ में आ गया डिफरेंस कि where delta x was equals to this and delta is equals to this, उल्टा होता है, just the reverse happens in the case of diffraction. Clear? Whenever you're done writing, just tell. Acha, in both the case, guys, if I want to find out the relation between this is basically the y and this distance is capital D. So I'll always say y equals to d tan theta over here as well. And if I say similarly, if this distance is d and this distance is y, then again I'll say y is equals to d tan theta. This relation is valid in both the cases, right? Only this condition, the other one too. Clear hai, guys?
Yes, sir.
So this is basically the difference between your interference and this thing. But practically, if we speak now, practically you cannot, if you see a pattern, let me tell you, interference pattern YDSC, show me an image. Yes, guys, are you able to see this image? Guys, are you able to see this image?
Yes, sir.
Yes, sir.
Please see in this particular thing what is diffraction phenomena and what is pattern. Can you see these fringes forming? Guys, can you see these fringes getting formed? These fringes are because of what? These fringes are because of interference fringes. But please remember, even if you have interference fringes, can you see the diffraction pattern? Can you see over here? Can you see a diffraction pattern? Can you see the intensities of this particular thing is reducing as you go away, right? So anytime if you try to do interference, only interference, it's not possible. Always interference will be accompanied with diffraction phenomenon. And you can vary this particular thing. This is basically your first, this is basically your first central maxima in the case of what? Diffraction. और भी हैं इसके बाद में इधर भी आती हैं ऐसे, and some more come over here, right? So what is this? This is the whole thing is because of central maxima for diffraction. So in general, when you try to do this particular thing, it looks like this. This is the first bright for diffraction. And can you see first dark over here? First dark over here. Yes or no? Guys, is it clear? समझ में आया? So basically what is happening, interference and diffraction phenomena are formed simultaneously only, but it depends upon us what we need to study. If we want to study only interference, so we'll just focus on these parts. If we want to study diffraction, then we'll just focus on the whole thing. Is it clear? Is it clear, guys? Shall I copy one more example? Copy image. Now, can you see it, guys? Guys, can you see? This is the central bright, then first bright, the second bright. Can you see the intensity is keeping on decreasing? Yes or no?
So
Anji?
for the full, like the whole set which we made, that is for diffraction.
Ha, the full set is basically for diffraction. That is the central maxima which we talk. है ना? But can you see the fringes? एक, दो, तीन, चार उंगलियों जैसी structure, right? These fringes are because of interference. So always remember, whenever you try to make a study an interference pattern, diffraction accompanies by default, है ना? तो diffraction तो आएगा ही आएगा उसमें. Is it clear, guys? Understood? Guys, is this clear? So
Yes, sir.
generally whenever we try to draw for intensity graphs for the pattern for diffraction, and it looks like this. Suppose if this is the screen, then it looks like this, you know? And as soon as you try to go away, this actual curve, so they start getting curved. When you get too far away, they start getting hyperbola. The central one will be bright, then you will get a dark fringe, then again you'll get a dark fringe over here. Are you getting my point? ऐसा कुछ पैटर्न दिखता है. So the intensity, if I try to draw the intensity versus distance curve, then the intensity looks like this. Almost similar intensity, है ना? ऐसा एक कर्व बना लेना. Wait, let me just delete this. Curve. Yes, guys, can you see a curve like this? Guys, can you see, if you want to draw only for interference, then you'll draw a curve like this. Okay. If you want to draw only for diffraction, can you see the height of the peaks is basically the same, right? In the case of diffraction, what is happening? Guys, in the case of diffraction, what is happening? This thing. And what about together? Can you see together? The red one. So the red one is basically the graph for this. Is it clear, guys? Understood? Can you see at this particular point it is you are getting completely dark? So basically that point corresponds to this. The next one is this. The बीच में एकदम बीच में fringe के this point corresponds to this, and so on. So please remember these graphs are important. Generally, your teacher asks you to draw the graphs, you know, uh, for interference and diffraction. So this can be a interference pattern. बना लो. Is it clear, guys? Hello, guys. Is it clear?
Yes.
Now we'll discuss the resolution. Resolving power of optical instruments. Okay. Guys, shall I move on? Please draw this graph. Na? The for interference you'll draw the purple graph. For diffraction you'll draw the blue graph. And if you want, I can continue this blue graph like this. है ना? Is it clear, guys? Understood how it will continue? ये मैं ड्रॉ करना है. ये this is not important. चलिए नेक्स्ट हेडिंग डालें. Resolving power of for optical instruments, whatever of optical instruments. So guys, in the last chapter, optical instruments, when we were discussing, about telescope and all, I told you about, there will be one point where you'll be need to resolve it between two. अब so suppose करो, I have a double star system, और वो बहुत दूर है मुझसे. So how will I be able to distinguish that it's two different stars, not only a single star? Yes or no? So basically, I need to be able to resolve the two images of those two stars. Then I'll be saying, no, it's a two-star system, not a single star system, right? Are you getting my point, guys? So if I want to resolve between, two different images, then this resolving power as a concept comes into play. Is it clear? Guys, is it clear?
Yes, sir.
Okay. Now, suppose let's say I have a lens, circular, spherical lens. So ये मेरा spherical lens है, because generally in astronomical telescope we use spherical lens only, right? So suppose I have a spherical lens of radius A, and let's say I am incidenting plane, a parallel incident rays, because the object is far away. So basically I'm incidenting plane wavelengths, right? Is this clear, guys? You understood what exactly I'm doing? So suppose guys I'm incidenting a parallel beam of light over a convex lens, then what will happen? If there is no spherical aberration happening over here, then what will happen? Can you see these edges? Can you see the edge of this spherical? Can you imagine the whole edge of this spherical mirror? What will happen to this sharp edges? Diffraction phenomena will occur, right? Yes or no? Yes or no?
Yes, sir.
Yes.
So basically, what happens because of a diffraction phenomena? You can write it over here. Because of diffraction through the edges of the lens, the light does not the light does not get focused to a single point, but it makes a spot. It makes a spot of finite area. So basically, what is happening? Suppose if I have a screen in front of it, suppose in case if I have placed a screen in front of it, then on this screen you will not get a point image. If it is placed at the focal length of this particular thing, then you will not get a point image, although you will get what? A spot of finite area. So basically, how will the pattern look like? It will look something like this. There will be a small circle, then followed by certain z, followed by certain disk, or you can say ring like structure on that. Close to guys, are you understanding this particular thing? तो यहाँ पे एक सर्कल बनेगा, then there will be a dark fringe like this, then there will be this disc, then there will be dark, and so on. Guys, understood? ऐसे ये ऐसे rings बनती जाएंगी और finite area. So guys, are you understanding this particular type of pattern which is getting formed? Yes or no? इनका radius small होता है. This is a little bit big. Is it clear? So basically what happens, the radius of this particular thing, the intensity varies like this, यहाँ पे थोड़ी ज़्यादा हो जाएगी, then फिर कम हो जाएगी, then फिर ज़्यादा हो जाएगी, then फिर कम हो जाएगी, and so on. Same pattern goes over here as well. So this is how the pattern gets formed in the case of when you have a convex lens, and you try to see when diffraction takes place through the edges. Then in the ray of light does not concentrate at a single particular point. It concentrate over this particular area. Okay. The radius of this particular thing R, the radius is given by 0.61 lambda f by a, or basically 1.22 lambda f by 2a. 2a is basically the diameter, right? So this R, hello,
Yes, sir.
है ना? So ये is part of finite area. I told you, no, कि the light ray gets uh, does not get focused to a single spot, but it makes a spot of a finite area uh, whose radius is given by whose radius is given by. Then you will write R is equals to this. Is this clear? The derivation is not there in the syllabus, but see the result. Can you see a central bright region, guys? Can you see a central bright region on the focal plane? And then there are concentric dark and bright rings, right? Central bright circular disk followed by dark and bright rings. So this is the pattern which gets formed. The radius of this bright portion is basically given by R naught equals to R equals to 1.22 F lambda by 2. Is this clear, guys? Is this clear, guys? Now I think you can see one particular this thing. This is basically the center of the lens, optical center, and let's say this is R naught. This is the circle which is found on the way here, and this is the convex. थोड़ा सा बड़ा डायग्राम बना रहा हूँ तो समझ में आए. So let us assume this angle is basically delta theta. This distance where it was forming, it was F. So this spot is, we know this spot is very small, but it will play a very important role in determining something called as the resolving power. ठीक है? So basically from here, can you see this particular thing, guys? Tan theta is equals to R naught divided by F, and always remember theta will be very small. This resolving power will be very small, theta will be very small, so you can say theta is equals to, or delta theta is equals to R naught into F, or from here you can say R naught is equals to F into delta theta. ठीक है? अब sir, why are we doing this? Because we want this particular delta theta. This delta theta is basically called as the angular resolving power, or you can say ठीक है. So delta theta is equals to R naught by F, and we just wrote R naught is basically 1.22 F lambda by 2 divided by. So can you see, guys, delta theta is equals to 0. Approximately, everything is happening in approximation. 0.61 times of lambda by, ये याद रखना, ये आपका रिजॉल्विंग पावर है. ठीक है? अब can you see, guys, over here delta theta is inversely proportional to A, right? So जितना बड़ा radius of the lens will be there. अच्छा, by the way, this distance was A, if you remember. जितना बड़ा radius will be there, the resolving power will be less, right? Yes or no? So you can say this particular thing. एक second, एक second. Uh-huh. Array, guys, please remember this delta theta is not related with angular resolving power. You can relate it with resolving power like this. I got confused. Sorry. Hmm. So if delta theta is small, that implies we can resolve two images at a smaller distance from each other, and that implies resolving power is more. ठीक है, ये याद रखो. So if A is large, that implies delta theta will decrease, and that implies resolving power of the lens will be more. ठीक है, इतना लिख. So that is the reason people generally say for a better resolution, through a telescope, the diameter of the objective lens shall be more. Is it clear? Is it clear, guys?
So could you scroll up 1 minute?
Sure. I'll just minimize it. और ऊपर करो.
No, sir, only the note.
Acha, please remember this 1.22 f lambda by is not there in your derivations, not even in J. It comes in MSc or BSc second year or third year. Because when I studied this particular thing, not in college, when I was preparing for teaching people, तब मैंने I asked one of my friends who did BSc in physics. So I asked him कि भाई ये फॉर्मूला आता कहाँ से? So he said कि ये सेकंड ईयर थर्ड ईयर में इनको एक डेरिवेशन है. Then तो मैं ठीक है, अच्छा है. What I need to do if it's not part of JEE need, so let it be. That is done. तो ये रिजॉल्विंग पावर लास्ट मुझे पढ़ाना था. That's the only thing which was clear. Sorry. With this thing, I'm done with diffraction. Now let's start with something called as polarization. Okay, shall we start?
Yes, sir.
ठीक. Now, what is polarization phenomena? Before understanding polarization, everyone knows that light is basically transverse wave. Light is a transverse wave, right? Yes or no? Or you can say it's a transverse electromagnetic wave, right?
Yes, sir.
So if light is a transverse electromagnetic wave, and please remember, in the case of light, always remember this thing that there are two. In the case of electromagnetic waves, there are two, fields. One is the electric field, and one is the magnetic field, right? Although I have not, I think I skipped this chapter. Na electromagnetic waves as of now.
Yes, sir.
ठीक है. So still, I'll give you a basic idea. Suppose let's say this is your x, y, and z axis. Okay, z axis is coming out of the plane. So now, guys, can you see over here? Whenever you have an electromagnetic wave, what happens in the case of an electromagnetic wave? There are two fields. One is basically the electric field. Can you see a sinusoidally oscillating electric field? This is the electric field. Okay, E is equals to E naught sine of kx minus omega t. Right? This is the electric field. Let's say it is vibrating in xy plane. And propagating along. Can you see, guys, this wave? This is propagating along x. Acha, how does the direction comes? The direction comes from here. If it is a minus sign and x written, then it is going along x-axis, right? If it's a plus sign over here and x written over here, then it goes in the opposite direction. Anyway, similarly, parallel to, perpendicular to this, thing, we have another magnetic field which goes like this.
So that's in the ZX plane.
Yes, it is in the ZX plane.
Okay.
So guys, can you see over here? This maximum amplitude is basically equals to B naught. And this plane, it oscillates in this plane, right? Can you see this? The magnetic field is oscillating in XZ plane, whereas the electric field, I'll write the equation for the magnetic field as well. B is equals to B naught sine of kx minus omega t. Can you see the time? Omega is same for both of them. है ना? This is basically vibrating in xz plane and propagating along x. ठीक है? Guys, can you see the difference between both of them? समझ में आ रहा है थोड़ा डायग्राम कैसा है? Guys, can you understand this particular thing? एक सेकंड जल्दी चलो. The electric field oscillates like this, whereas the magnetic field oscillates like this. एक का plane of vibration is like this, one plane vibration is like this, and can you see these two planes are intersecting at x-axis? तो जो भी इन दोनों प्लेन का इंटरसेक्शन होता है along that direction, the wave propagates with a speed. The wave propagates with a speed c. And by the way, please remember this c is equals to E naught by B naught. ये E naught और B naught दिख रहा है? ठीक है? Is this clear, guys? Electromagnetic wave. ये समझ में आ रहा है? Why it is called as transverse? Can see the wave is traveling along x and it is vibrating in x y along y direction, right? Yes or no? So basically, you can say this wave is oscillating. This electric field is oscillating perpendicular to the direction of propagation. Hence, transverse. Is it clear, guys? Is it clear? Hello.
Yes, sir.
So the direction of propagation is in this direction, and of propagation of electromagnetic wave is along x. So क्या आप देख पा रहे हैं यहाँ पे there is one electric field and there is one magnetic field, right? There is one electric field and there is one magnetic field, which is so two perpendicular electric field and a magnetic field oscillate with respect to each other, and the direction of propagation is perpendicular to the direction of vibration.
So is the speed E naught by B naught?
E naught or V naught.
Okay.
ठीक है? Is this clear, guys?
Yes.
Now let's talk about the ordinary light. है ना? What is an ordinary light? See, the light which you know as of now. अभी तक जो भी light तुमको पता है, it's basically what? An ordinary light, right? What happens in this ordinary light? The electric field oscillates in all possible directions. The electric field oscillates in all the possible directions in along the 360-degree, right? And the it is traveling along x only, but can you see that plane is not necessary xy only, no? It can be any particular plane, right? Which is perpendicular to x-axis, right? In all possible directions perpendicular to its direction of propagation. So we say that these vibrations, these oscillations or these vibrations of electric field are uniformly distributed symmetrically in all directions. Perpendicular to the direction of propagation. This type of light is basically called as an ordinary light. ठीक है? This type of light is called as ordinary light or basically an unpolarized light. Is it clear, guys? Shall I write this light is called as unpolarized? Okay, na? Declare definition. It is denoted by like this. Suppose this is the ray of light. This is the ray of unpolarized or ordinary light. Then how do I represent this particular light? I represent it like this. I represent it like this. What does this represent? What does this represent? That the vibrations are distributed in 3D, है ना? अच्छा, please remember, it's a it is distributed in three dimensional, है ना? सिर्फ 2D diagram बनाते, that does not mean symmetric in 3D, है ना? ये ध्यान रखना. Either you draw it like this, or simply you can just draw it like you can just simply draw, either draw it like this, or draw it just simply like this. Draw an arrow, draw an arrow, draw an arrow, draw an arrow, and on these arrows here draw dots. Okay, what does arrow represents? This is also the ray of unpolarized. This is how it is represented. The arrow represents the vibrations which are in the plane, and the dots shows the vibrations which are perpendicular to the plane. So basically, can you see over here, the arrow shows, these vibrations are happening in this plane only, the plane in which which we are writing, right? So vibrations are happening like this, whereas the dots represent vibrations are happening perpendicular. Is it clear? And what does the this arrow represent? ये वाला क्या represent कर रहा है? What does the green one represent? Guys, what does the green represent? This arrow represents what?
Direction of propagation.
Yes, the direction of propagation. So always remember, whenever you will draw an ordinary light in case of polarization chapter, you will draw it like this. ठीक है? Is this clear? Polarization, sorry, unpolarized और ordinary light clear है जो अभी तक पढ़ी है अपन ने? ये समझ में आया कि how is the electric field vibrating, right? And why am I talking only about electric field in the case of light? Because in light this electric field is 70% prominent. So generally, मतलब 70% energy we consider it as what? Electric energy in the case of light. Clear? लिख लो. And guys, give me 2 minutes. I'll be just back. Yes, guys, are you done?
Yes.
Let's understand what is polarization. So you can write the phenomena in which the vibrations of the light are restricted in a particular plane and limited to vibrate in a fixed plane is called as polarization of light. So basically, I want to do what? I want to restrict. Can you see this electric field was oscillating in all possible directions? I don't want this electric field or this light to vibrate in all possible directions. I want the plane to be restricted. Then how do you see this particular thing? You do it using something called as polarization of light. This phenomenon. Okay? The devices which restricts the vibration of unpolarized light. I'll just show you a video, don't worry. Then its crystallographic plane are called as polarizers. Example, there is something called as a tourmaline crystal. There are many others as well, but I don't remember the name. There's different are there, so etc. मैं आगे कहूँगा. Guys, have you seen those polarized glasses by Ray-Ban?
Yes, sir.
Have you ever went to buy them?
Yeah.
So जब उनको खरीदने जाते हो, so they make you wear those glasses. पहले तो बोलते हैं कि sir look at this particular sheet of paper, and then in once you look at that, you can't see anything, and फिर उसके बाद बोलेंगे sir अब glass पहनो. So then you wear the glass and then again see it, then you will see something. What exactly is happening in that particular case? you know they the sheet which they have created, they have created in such a way that it can be seen only in a one particular plane, right? And when you wear those glasses, that plane or basically that light which was not visible to you gets visible suddenly. So that is why, you know एक second, let me just polarizer. No, experiment लिखना. Guys, you don't need to focus on what exactly this guy is saying, or basically what just happened. Guys, yes, guys, can you see there is something which is this guy is holding in his hand. This is made up of a polarizer crystal, or basically let's say tourmaline crystal, है ना? How does this thing happen? Can you see over here? They have mentioned, this particular arrow. Can you see over here? Hello.
Yes, sir.
तो ये arrow is basically representing its crystallographic axis, है ना? अभी थोड़ी देर में देखो what will happen, when he will rotate this particular thing. अभी can you see whatever is happening just behind it? Can you see whatever things are there which are behind it? Can you see it? है ना? Are you able to see whatever is behind this particular thing?
Yes,
Yes.
sir.
So basically light from this object is coming through this polarizer and then entering the camera, मतलब then entering your eye, right? So now you are able to see everything because अभी देखो क्या होगा थोड़ी देर. Abhi dekho guys, what exactly happened, can you see over here when he used this torch, and when he sent it through this particular thing, you were able to see the light, whether he was like this or that axis. Although ये experiment उसका है दूसरा है, but still, है ना? This will help. एक second. So अभी क्या हुआ कि when the light was coming, the intensity just got reduced. Can you see over here? If you look at the light, guys, can you see over here the light intensity when this torch was over here? This was something different, and when it was passing through the polarizer, it was something different, right? Yes or no? So basically, when an unpolarized light passes through a polarizer, then it restricts by half. But he is basically giving an experiment in which a polarized light passes through another analyzer, one more device, the same thing, another type of polarizer. तो अब गौर से देखना ना. Yes, guys. Can you see, guys, when he rotated it? Guys, can you see when he rotated it? What happened? This whole thing became black. Guys, can you understand this particular
Yes,
thing?
sir.
This whole thing
Yes,
became black. Why does this become black? Its intensity became zero. Intensity becomes zero. That implies now you are not able to see any light which is coming from this particular part of the experiment, right? So can you
yes,
see
sir.
over here? Basically, what did he do? This lens, can you see the previous lens which he used? That lens was basically turning unpolarized light into polarized light. But when that polarized light, it's passing through another polarizer. Can you see? You are not able to see anything. So why? Because in this case, the light which is coming from this previous one, it's basically having what? The electric field is vibrating in some other place. By rotating the crystallographic axis, you are not letting any vibrations which are in that particular plane. So basically, can you see this is the process in which I have restricted the plane of vibration, right? Yes or no? This phenomena is basically polarization. एक और इसके पहले वाली वीडियो भी दिखा देता हूँ. एक सेकंड. Yes, guys, see, normal lens. This is a normal, this is not a polarizer. It's a normal lens. Normal specs which you have. See, can you when you rotated it? Can you see in the case of polarized glasses what happened? The glasses, did the glasses change their color?
Yes, sir.
Actually, glasses did
Arjun.
not change the color. You are not able to see any light through these glasses. Glass का color अभी भी
Yes,
होता है,
sir.
but the light which is coming from the, do you remember, you were not seeing the glasses, you were seeing the light which was coming from the computer screen, right?
It just blocked the thing.
हाँ. So basically क्या होता है कि लाइट को ये ब्लॉक कर देता है, पोलराइजर दे रिस्ट्रिक्ट द प्लेन of, they restrict the vibration to a specific plane only. So when this thing was straight, can you see, when this thing was straight, it was letting the light come through, but as soon as you rotate it, it blocked all the light. Are you getting my point? So this phenomena is basically called as polarization. Understood? क्या होता है पोलराइजेशन, समझ में आ गया सबको?
Yes, sir.
Yes, sir.
ठीक. So basically these devices are called as, polarizer. These polarizers have a crystallographic axis, and see, just for example, what will happen, suppose if I have an unpolarized light, and let's say this is my unpolarized light, and in this unpolarized light, the electric field is vibrating like this. Can you see the arrows and the dots? They are together. So what kind of light is it? What kind of light is it?
Polarized light? No idea.
Unpolarized light. Arrows or
But
dots,
so
whenever they are
unpolarized.
together, it's unpolarized light. Okay, it's ordinary light, right? Hello.
I'm confused.
अरे अभी मैंने ऑर्डिनरी लाइट ही तो बताया है भाई, पोलराइज तो बताया नहीं है. This is the ordinary light, right? Unpolarized or ordinary light, dots and arrow together.
But why did we write like, oh, okay, fine, it's just the other notation.
So this is an unpolarized light, and now let's pass this unpolarized light through a polarizer. Okay, so guys, can you see the polarizer? This is our polarizer, and let's say this is the crystallographic axis. So basically what does this crystallographic axis means? Ki it will let whatever vibrations which are along the crystallographic axis, it will let them pass, whereas whichever which are not along this particular thing will, at least whichever which are perpendicular to it, it will block it. Okay, so basically what happens, कि when the light comes out of this particular polarizer, it's no longer unpolarized. With the help of this polarizer, you have restricted the plane, and the light becomes something called as polarized light. So can you see just an arrow, no dots? So can you see only those vibrations were left which were having, only those vibrations were left which were having, which were along the crystallographic axis, right? Yes or no? This is called as a polarized light. Is it clear? If if the same experiment would have been repeated, but with the polarizing, crystallographic axis like this, can you see guys, now the crystallographic axis is like this, It's perpendicular to this particular thing, right? So here when light comes out of this polarizer, it won't be polarized like that, but it will be polarized like this. Let me just draw it. Okay, so this is also polarized light, but can you see only those planes were there, only those vibrations were remaining which were parallel to the crystallographic axis. एक बार मैं और समझाता हूँ. Guys, suppose these were your the diagram looks like this. This is unpolarized light, right? Yes or no? I have drawn it like this. Can you see one plane is one vibration is basically coming out of the plane? Okay, can you see one vibration which is coming out of the plane? This one.
Yes, sir.
Yes. So basically this is your unpolarized light, and let's say this is your polarizer, है ना? So can you see over here? थोड़ा पिक्चर कर लेना है इसको, है ना, ऐसे. So this is how the diagram is drawn. अब ये light ऐसे की, when the light goes like this vibration, let's say if the crystallographic axis of this particular thing is like this, ऊपर से नीचे तक, in a vertically downward direction, or basically vertical direction, then if you pass this unpolarized light through this or through this polarizer, then ये जो vibration है ना, this vibration which was perpendicular to the plane, this gets blocked. So after passing through it, only this plane remains. Are you getting my point? Understood?
Yes, sir.
And in the second case, again the same thing is there. But I have placed the tourmaline crystal like this now. Can you see? I have placed it like this. So now the crystallographic axis is like this. So basically when it passes through this particular thing, now which plane will get blocked? This or the one which is coming like this. So now this will get blocked. Ye block ho gaya. And after passing through this, it comes like this. Are you getting my point? Understood?
Yes, sir.
So this is your, this is phenomena is basically called as what? Polarization, and this is how you restrict the plane. Whichever plane which is whichever vibrations which are along the crystallographic lines, they get passed through the polarization, and whichever which are not, they don't get passed. So we can write this particular thing. Only those vibrations which are along the crystallographic axis passes through the polarizer and those vibrations which are perpendicular to the crystallographic axis gets completely blocked. We'll see the reason very soon later on in the chapter. Is this much clear, guys? Guys, is this much clear? Hello?
Yes.
Yes, sir.
After defining this particular thing, there are two planes which we need to define. There is one which is called as the plane of vibration, and the one which is called as plane of polarization. So suppose guys, in case number 1, when the polarized light were looking like this, let me draw the diagram fast. Control C. Yes, guys. Can you see these two planes? And can you see their line of intersection? Can you see these two planes are intersecting at this line, which I will be drawing over here? This figure makes much more sense as compared to previous one. So, anyways, done. Assume this is over here, right? So now see this particular thing, guys. Let's say the initial polarized light was like this. Let me just control C. Let's say our polarized light was over here and the plane of vibrations were like this. This is case 1 which I'm talking. Only arrows are there. Guys, can you see only arrows are there over here? So can you say two planes? One is basically, I'll name it A, B, C, and D, and let's say another one is E, F, G, and H. So for this particular light, case 1 which I'm talking, can you see the vibrations are along in the plane ABCD? Yes or no? Vibrations are in the plane ABCD. Similarly, if I talk about these particular things, so if I have dots, so guys, these dots basically means what? Now the vibrations are in a plane which is perpendicular to this particular thing, right? Ayana, the dots basically means this, right? Yes or no? So ये रहा. So in this particular case, the vibrations are not in plane ABCD. The vibrations are in which plane, guys? थोड़ा समझ में आ रहा है diagram? I know it's diagram is a little bit weird, but I think it's understandable, right?
Yes, sir.
So here the vibrations are in the plane E, F, G, H. ठीक है? So what is basically plane of vibration and plane of polarization? For a polarized light, we define two planes. First is basically the plane of vibration. This is the plane in which the light or in which the vibrations are still present, right? Yes or no? So basically, these planes for which the light rays are the vibrations are still present are basically called as what? The plane of vibration. So basically here which I have drawn, no, A B C D is basically the plane of vibration. In the second case, the E F G H which I have drawn is basically the plane of vibration. Is it clear guys? समझ में आया वाइब्रेशन क्या होता है? प्लेन ऑफ वाइब्रेशन इज क्लियर guys? Is it clear?
Yes, sir.
Yes, sir.
ठीक है. The second case is basically the plane of polarization. So what is basically the plane of polarization? It is a plane which is perpendicular to the plane of vibration. In this plane, the vibrations have been completely stopped. Is it clear guys? So what is basically the plane of polarization in this case? The EFGH is basically the plane of polarization, and in this case ABCD is basically the plane of polarization. Clear है दोनों planes? Is it clear guys? क्या आप देख पा रहे हैं? In both the cases the vibrations are perpendicular to the plane of polarization. In polarized lights, the vibrations are perpendicular to the plane of polarization. ये थोड़ा सा छोटी छोटी चीजें हैं definition wise, remember them. Is it clear? And the last definition which I'm going to give you is basically a plane polarized light, or basically a polarized light simply. What is the plane polarized light? It is a light in which the vibrations have been, the direction of vibrations of electric field is confined to a single plane, is called as basically a plane polarized light. And we have already defined, we have already given the diagram. It is denoted by either arrow or either dot. Don't draw it together. Either arrow or either dot. Is it clear? This is your plane polarized light. Is it clear guys?
Yes, sir.
Okay. In the next class, we'll be completing this particular thing. We'll do polarization by reflection, refraction. There are different other things as well. There is something called as Nicol prism, dichroism, but वो इतना सारा मैं नहीं पढ़ा रहा हूँ. We'll be just talking about polarization by scattering, reflection, refraction, and then Malus law and Brewster's angle and all. And that's it. ये चैप्टर भी नेक्स्ट क्लास में खत्म हो जाएगा. छोटा सा ही है, it's not big. And with that thing, we'll be done with your wave optics in tomorrow's class. ठीक है? कल है ना क्लास? Tomorrow we have class, right?
Yes, sir.
So
Yes, sir.
by tomorrow, it will be over. And ठीक है, बस that's it for today. On Friday, I think we'll start with this thing. What do we call? Modern physics. ठीक है, we'll start with photoelectric effect. and we'll try to finish our syllabus by the end of November, है ना? छोटे छोटे chapters है. Now only small chapters are remaining. The chapters are not big. You'll feel like the chapters are very small, and their things are very going very quickly. But chapters छोटे छोटे हैं यहाँ पे. There are simple concepts and simple explanations and all. So is this clear, guys? In the next class, we'll
Yeah.
be done with polarization, and that will be it for. At least I have taught till JEE mains and NEET level, and advanced level I have not taught of as of now. Although please remember, it's not necessary that NEET people do not want to study and all, but take it. I know that advanced portion is not there in your syllabus, but still sit in those classes. You'll learn something new at least, है ना? So, anyways, chal. Thank you very much, guys. We'll see you again.